This genuine Unreal Engine 5.5 run begins with a 10 by 8 grid, 12 blocked cells, a cyan start, and a green goal. A star explores 55 reachable cells, reconstructs a 25-node route around 2 walls, displays that path in green, and moves the agent along every node until its goal distance is 0. In this lesson, we will represent cells with FIntPoint, store obstacles and close nodes in TSet, track scores and parents in TMap, calculate Manhattan distance, choose the lowest F score, expand 4 directional neighbors, reconstruct the path backward, move an actor through the result, and verify the algorithm and native Unreal presentation with automation and 4 real frames. Each cell is an FIntPoint with integer x and y coordinates. Grid width is 10 and height is 8. Start is 0, 1 and goal is 9, 6. A TSet of FIntPoint stores 12 blocked cells, giving constant time membership checks during search. The conversion from cell to world position is kept in one function. It centers the grid and multiplies each coordinate by cell size. Search remains pure integer logic, while visualization applies world transforms afterward. This separation makes the algorithm easy for AI to write, test, and reuse without depending on meshes or frame rate. Open contains discovered cells that may still be expanded. Closed contains cells already processed. GScore maps each cell to the cheapest known cost from start. CameFrom maps a cell to the previous cell on that best route. This small tutorial stores open in an array and scans it for the best candidate. That is readable and perfectly adequate for 80 cells. Large worlds should replace the scan with a binary heap or priority queue. The surrounding a star logic remains the same, but selection becomes logarithmic instead of linear. A star ranks each open cell by F equals G plus H. G is the exact cost already traveled. H is a heuristic estimate to the goal. With only up, down, left, and right movement at unit cost, Manhattan distance is the absolute x difference plus the absolute y difference. This heuristic is admissible because it never overestimates the shortest remaining route on this grid. If diagonal moves are allowed, use a matching diagonal or octal heuristic. A heuristic that disagrees with movement rules can return inefficient paths or break optimality. For the current cell, generate 4 neighbors. Reject coordinates outside the grid, blocked cells, and cells already closed. Tentative G is current G plus 1. If the neighbor has no score or the new score is lower, update CameFrom, update GScore, and add the neighbor to open if needed. The runtime also records each expanded cell in an explored set. That data is not required to find the path, but it drives the Amber search visualization and gives regression tests a useful measure of algorithm behavior. When the selected cell equals the goal, search has finished. Begin at the goal, repeatedly look up CameFrom, and append each parent until reaching start. The collected list runs backward, so reverse it once. The result begins at start and ends at goal. A validation function checks both endpoints, confirms every cell is inside the grid and not blocked, and requires Manhattan distance 1 between consecutive nodes. The agent can now consume the array from index 1, using constant speed interpolation from one world point to the next. These are 4 genuine game mode frames from one Unreal execution. Grid Ready shows blue walkable cells, red walls, start, goal, and 0 explored cells. Search turns 55 expanded cells amber. Path Ready overlays 25 green route markers through both wall gaps. Arrived shows the agent glowing green at the goal with step 25. The tile instances, obstacle geometry, explored overlay, path markers, lights, shadows, state text, and agent movement all come from the compiled C++ project. They are not generated diagrams standing in for runtime output. The Unreal automation test passed with 1 success and 0 warnings or failures. It rebuilds the 2-wall grid, verifies a star finds a route, checks every node is in bounds and obstacle-free, confirms consecutive cells are adjacent, proves the detour is longer than direct Manhattan distance, requires more than 20 explored cells, and verifies a sealed wall returns no path. The off-screen runtime then proves a 10 by 8 grid, 12 obstacles, 55 explored cells, 25 path nodes, 4 captures, a valid reconstructed route, and final goal distance 0 with valid true. Together, these gates cover algorithm failure cases and the complete Unreal presentation. The reusable pattern has 4 parts. Model integer cells, bounds, obstacles, start, and goal. Search with open, closed, GScore, CameFrom, and a heuristic matching the movement rules. Reconstruct and validate an ordered route. Convert cells to world positions and move the gameplay object through them. For large maps, use a priority queue, reuse allocations, limit search work per frame, and consider Unreal Navigation System when a NAV mesh already fits the game. But for tactics grids, puzzle boards, procedural dungeons, and custom movement costs, a star is an AI-friendly C++ system because its inputs, invariants, and visual results are explicit and testable.